has served in the Civilian Department of Defense position since August of 2009. Mr. Abbott is responsible for establishing and managing the policies, processes, and reporting metrics that enable Hill Air Force Base to operate its facility energy delivery systems in a resilient and efficient manner. He and Mary Boyle will be presenting about clean energy and energy security at Hill Air Force Base, the focus of which is the Air Force Facility Energy Plan, built upon 3 pillars that guide energy management: increased supply, reduced demand, and culture change. Second Lieutenant Mary Boyle is a 2014 graduate of the Air Force Academy, where she received a Bachelor of Science degree in Civil Engineering. She is presently working as the Hill Air Force Base Energy Manager, driving Hill Air Force Base to achieve federally mandated energy reduction goals. Jacob Kane is currently the Director of Plant Operations for Weber State University. He was the Energy and Sustainability Manager at Weber State University since 2008. He has a bachelor's degree in applied physics from Weber State, as well as an MBA from Weber State University. He has a number of industry certifications, including, but probably not limited to, Certified Energy Manager, Renewable Energy Professional, Certified Building Commissioning Professional, Certified Lighting Efficiency Professional, and a Business Energy Professional, Educated Facilities Professional, and a Lead GA. Wow. All right, without further ado, I'll turn the time over to our speakers.
So, like my wonderful introduction said, I'm the Energy Manager at Hill Air Force Base, and I'll just be giving you an overview of our program and how it relates to DoD policy and Air Force energy policy and how that comes down and affects what we do. So, you guys got the Air Force format for this briefing. So here's the purpose. It's to present attendees at the Sustainability Summit with what we do at Hill. And then here's the overview. I'll just go over the Air Force energy pillars and how they tie into strategy and Air Force energy plans. And then I'll go straight through all the pillars. And me and Dave will switch off after I talk about one. So here's how the Air Force energy plan kind of ties in with DoD energy policy. It's kind of important to note that the Air Force is very unique when it comes to its DoD counterparts. We use 64% of the energy in all of DoD. And we are also the largest consumer of federal energy as well. We are the biggest renewable energy contributor, and Hill Air Force Base contributes 27% to the entire Air Force portfolio. So we do a lot of Hill in terms of renewable energy, and here we're looking to do one. And so you can see these are just the pillars of the energy plan. For increased supply, one thing that's been emphasized a lot lately as it ties into health is energy security. As cyber threats continue to grow globally, we have been pressured and we're kind of being moved towards making our structure more resilient. And so doing more things on base and where possible using renewable resources to do that. And we're also looking into combined heat power. So I'll be covering the increased supply pillar. And the first part of this is the solar array we have on base. This is a 225 kilowatt PV array. We were able to get funding for this through an ESPC contract. They're kind of unique. Basically, we work with an escrow, an energy savings company, and we get third-party financing, and we pay for all of this through a 20-year performance period, and that's paid for out of the savings in our energy bills. So, as you can see, this was commissioned in June of 2009. And we pay for this, it's bundled with other ECMs. So this might not have been a 20-year payback, but combined with steam traps or like any other things like that that have a higher payback, we can get it down to that. And the current size of this is 22 total arrays with 48 panels, and we are planning on eventually expanding it up to 1 megawatt. The transformer size is 1 megawatt, so we're hoping eventually to either get some energy conservation funds from central funding or use another ESPC to do that expansion. The second way we do the second contributor to our renewable portfolio is methane gas from the Davis County burn plant. This is just piped in, and we have a facility on base that burns it like you would natural gas. And it's methane gas, the landfill generates it. And originally, we just had one combustion engine, it's a gin fokker, is that right? Two Caterpillars, and then we added on to it with another ESPC contract. And it has a 2.3 megawatt capacity. And then this is the biggest part of our renewable energy contribution to the Air Force's portfolio. This is 19% of our energy on base, and this is just piping steam in from the burn plant and using it on our facilities. This accounts for 30% of the energy used for facility heat on our installation, and this was, we renegotiated this. We just renegotiated a 10-year contract, and it's for 420 K-pounds of steam annually. And then going forwards, we're looking to increase our supply in a couple different ways. There's a large-scale geothermal opportunity out at the Uter for up to 1 gigawatt, but because of the costs associated with drilling and the uncertainty of finding that energy, we've kind of put it on hold, but it's definitely out there, and the Air Force has plans to expand their renewable portfolio in the future, and we could definitely be a part of that. We're looking at combined heat and power right now through an ESPC contract that we're piecing together, and this could be up to 3 to 5 megawatts, and we'll probably know by next year if we're going to go through with this or not. And then, as I mentioned earlier, our PV array size for a megawatt. So hopefully in the future we can expand it. Thanks.
Thanks, Mary. And as Lieutenant Boyle indicated, we believe we've got pretty good progress made toward it. So, in the reduction in demand, we take the maximum advantage of the Rocky Mountain Power Watt Smart Incentive programs. Not so much for the thermalize because of how we buy our natural gas, but between the air logistics complex and specifically military family housing. For those of you who don't know, there's well over 1,000 military family homes on the installation. They are served with thermalized gas, GS1 gas. They're eligible for thermalized credits. But recently, they've taken familiar with the base, and at night you see that kind of yellow glow around the base. Well, it's going to be a more whiter glow in the future. It's going to improve security and reduce energy. Centrally funded advanced metering projects. Jacob can tell you you can't manage energy if you don't measure it. Well, historically, in an Air Force installation or any DoD installation, they always measured the energy coming in at the fence line, but we never measured the energy in the facilities. We made significant progress over the last 10 to 15 years. We did meters on the building, so we know where the usage is. In Hill, with the mission that we have, it's a heavy depot maintenance workload, so we do a lot of aircraft maintenance type of work, a lot of industrial use of energy as well as facility use of energy. So it's a matter of pinpointing where that energy is occurring so we can make smart decisions and improve it. Construction estimated completion date, or the estimated completion date on the advanced metering system we anticipate to be November 2016. We're just waiting for the data acquisition server to tie all the data in. Energy savings performance contracts, Lieutenant Will mentioned a little bit about that. That's using other people's money, basically. The Air Force, as well as most of the military services, have a huge reduction in operation and maintenance budgets. So, utilizing this DoD contracting vehicle, we can partner with ESCO for energy services companies to help develop projects for us. We currently have 6 ongoing ESPC task orders in various stages of their performance phases. We've done things like the landfill gas facility, the PV array, We've done some infrared heating in some of the hangar spaces and things of that nature. So we're working to develop a new task order with Energy Systems Group currently. We received a preliminary assessment just earlier this week. We've got till like the middle of April to provide our comments to that preliminary assessment. The next step would be to move into what they call an investment grade audit. That's why they'll more further define what those energy conservation measures are prior to the work. Reduced demand peak shading. We've also looked at this with the support of our rim contractors that we have in the office. We looked at our peak demand. Hill Air Force Base's electricity can peak in the summer as high as 45 megawatts. That's a significant amount of power. The advanced metering will help us determine where that is occurring and where we can shift that load outside the peak times of running enough power. We're on a rate schedule 9, so we pay for those peak power usages in the summer at a much higher rate than we do in the winter months. So the ability to break this kind of information down at the building level will help us identify where those issues are. Reduced demand way forward, we continue to develop that peak shading program based on the metering data we anticipate to receive. Utilizing a potential for a combined heat and power plant for peak shading after the current ESPC is awarded. That's one of the energy conservation measures that they have proposed in preliminary assessment. It looks like it has a good return on investment, and we may move forward with that. And you continue to pursue utility incentives and award contracts that make sense to us. Investigate implementing real-time demand response technology. Automatic load shedding. Hill has a very large energy management control system. We reach out and touch literally hundreds of buildings and thousands of points, looking primarily at HVAC systems. So we're maintaining set points. We're doing night and weekend temperature setbacks and things of that nature. We can tie this metering data into our ACS system and be able to see that real time. Hopefully we can do some load shedding where it makes the most sense. Culture change is the third pillar of the Air Force's energy plan. This past summer, we stood up a water conservation action team. We had representatives from environmental, the ground maintenance contractor that maintains the grounds on the base. So they were all part of that team. And we had a 14% reduction in our summer water use. So we really focused on our irrigation systems and where we were wasting water. In addition to that, last year we put on a number of events to identify the cultural change. I think we're one of the only Air Force installations in the world that has a dedicated energy outreach coordinator. Now that helps us because what that does, it allows a full-time person to organize the type of things to really get the people involved. Hill is the largest single site employer in the state of Utah. We have over 25,000 people that report there every day, work, live, and play. And so having these kind of things brings those people together and understand that conservation is important. You'll notice that big 9-foot guy there in the picture with Santa Claus. He's our mascot, Colonel Conserve. We've had him for a couple of years now. Kids really love him. People see him smile every time he's around. We've had workshops. We have a golf tournament in June up at the Hubbard Golf Course on base where we invite all our business partners and municipal partners to come out. It's a fun event. And just continue our outreach efforts. We do Hilltop Times, the local weekly newspaper for the base. We do articles in the Hilltop Times. We do building energy contests, provide tours of the Hill Solar Array, and we also have a social media presence with Facebook. Going forward, in 2016, we're organizing Lieutenant Boyle's an avid runner, so we're going to have us a fun run in June. I'll kick it in for conservation, so we're going to partner with environmental folks and do that and have a fun day on the base. Golf tournament scheduled for 16th of June this year, and then again in October we always gear up for National Energy Action. Currently working with the DLA. The DLA is a large tenant organization on the base. They occupy probably 300,000 square feet of facility space. So we're partnering with them to implement a strategic energy management program, working again with the Rocky Mountain Power's Watt Smart program. They'll pay TLA about 2 cents a kilowatt hour for every kilowatt hour that they save. And a lot of this is just through low cost, no cost kind of opportunities that they get help identify. So end goal is full building level participation from the basic population. Conclusion, our business is to protect America. Our business is to fly, fight, and win as a military organization. We take that very seriously, but we also recognize that new coming out of the Pentagon is mission assurance through energy assurance. So recognize that you can't do one without the other. So we can do everything we can to use our energy resources more smartly. That's number one, we save dollars that can go back to the troops, to help the troops and their families, as well as it can advance the mission forward. Okay. I'll turn the time over to Jacob.
So I'm going to talk about carbon neutral capable term, kind of a funny term. Please, just a side note, if you have questions, go ahead and ask them while I'm talking. That way, as I'm going through this, I'll keep moving. So, yeah, just raise your hand, interrupt me so I can answer the questions I pass that particular slide. But carbon neutral capable is focusing more on that end use of energy and designing and building and operating homes, businesses, buildings, things like that are capable of being carbon neutral, rather than thinking of, I think the traditional idea is we've got to go kind of off-grid, somebody up in the mountains, on this, living on dirt and weeds or whatever, and that's what going carbon neutral means. And I'm trying to talk about the idea of something a little less extreme than that. So with that, you're going to have to talk about greenhouse gas emissions and get into that line of thought. Scope 1, Scope 2, Scope 3. Who's familiar with Scope 1, Scope 2, Scope 3? A few people, not many. Okay. So we really break down greenhouse gas emissions into 3 categories. Scope 1 is direct fossil fuel emissions from a given entity. So things that where you're actually burning a fuel, gasoline in your car, natural gas at a business or something like that. That would be Scope 1. Scope 2 is indirect greenhouse emissions from the consumption of electricity heat or something. For most of us, that means electricity. How much of our electricity comes from a coal-fired power plant or a non-renewable electric source. And Scope 3 gets into a myriad of other topics on how deep you can get with greenhouse gas emissions, but it's indirect emissions. So when I fly to Disneyland or whatever, how much fuel did the airline use in getting me there? How much carbon was emitted? Things like that. So they're not really owned or operated by the individual. And so that Scope 3 can get a little bit crazy depending on how far you want to go with carbon. So I'll be kind of careful in talking about that scope. All right, so this is nice little fun diagram. This is kind of Weber State University, a diagram of the energy flow for a carbon neutral capable campus. Now it looks kind of complicated. As you can see, we're still tied to the grid. Let's look in the top left corner up here. We'll purchase power from Blue Sky. We install our own solar panels on site. Then we get into high efficiency lighting and Energy Star systems and I call them the hybrid hot water heater systems, and then a central ground source system. Anyway, I just want to give a diagram up there. I'll talk a little more specifically about some of the concepts up there. But this is kind of, for us at Weber State, what we have envisioned, a carbon neutral capable campus. This is how the energy flows in such a campus. And there's a number of options that kind of fit that category. So fossil fuels, are they carbon neutral capable? No, not really. For us, we've talked about what's an acceptable amount of carbon. And for us at Weber State, that's pretty much the Bunsen burners in the science lab. Any carbon more than that is probably going to be more than we can plant trees per year and store carbon. So those are kind of some of the concepts. So for the most part, for us going forward, carbon neutral capable means predominant burning of fossil fuels has to stop, which, as you can imagine, is pretty challenging. So, okay, that chart's pretty crazy. This is kind of a world balance showing of where energy comes from as you look at different things. You can write down the website if you want, IEA.org. It's kind of a cool chart, but this is probably the more interesting one. This goes over, look at industry, transportation, and other of where energy is flowing. The big thing is most of our energy comes from oil, coal, and natural gas. Those are top ones. And then electricity was down here. So if I go back one, this is the power. This is all this stuff goes into that electricity number back there. So most of our energy, and this is how the power line, I mean, people have probably heard of this before, which is about 70% of your energy is lost just trying to get it from the power station to the endpoint of use. And that's kind of representing that. So, but I want to get more to that end use of energy. So for most people, what are you using end use of energy? And it's transportation's a big one, space heating, water heating, space cooling, plug load things you plug in the wall, things you hook up in throughout, electronics, etc. Lighting, and then industry gets a little crazy. Every industry has their own potential end uses of energy. It kind of varies. That can get complicated depending on the industry that you're in. But I want to talk about each one of those and talk about what a carbon neutral capable function of that may look like. So let's talk first about transportation. Options. There's the Flintstone method. Not many of us want to do that for going carbon neutral. I actually put a white volt up there because that's what I drive. I like a white volt. But electric transportation. So transportation is an incredibly difficult challenge to overcome when you talk about becoming carbon neutral. Almost all, I mean, even CNG has a lot of advantages. CNG produces far less carbon than other sources, but it still is a carbon emitter. So right now, as far as technologies moving forward that are out there, are hydrogen and electric are kind of really the only two out there that are carbon neutral capable systems. I think CNG and some of those kind of things have great interim steps and should be pursued in that kind of context, but long term, this is the future of reducing carbon is in these type of avenues. So a lot of electricity, or this is the new Toyota hydrogen, I don't know what the name of the vehicle is. I can't remember. It's kind of a funny looking vehicle. One of the penguins there. I'm not sure, but then I mean alternative transit. Particularly, I know some places are starting to use alternative electric buses, and we're seeing some more of that go around, and things like that. So electricity is definitely an option for can be sourced renewably. So that's a lot of this kind of moves in that direction. So, all right, let's talk about space heating. What are some ways to heat a space? In Utah, that's a big deal. We're a predominantly heating intensive state. We have about twice as many heating degree days as we have cooling degree days. That's how much is required in the state. So what options do we have? Well, you have geothermal. Now these terms are always mixed and matched a lot as I see them, geothermal and ground source. If you get very technical about it, geothermal is a little bit different than ground source. Geothermal is literally where you have heat coming out of the ground, so you're talking like lava hot springs. So I try to separate the terms a little bit so that it's a little clearer. Ground source is turning the earth into a battery. Those are heat pumps, ground source heat pumps. Where you're putting wells down in the ground, you're moving water underground and using a heat pump to heat or cool a building. So a lot of these are possible to install in homes. I think on the installation of a home, I don't know, Jeremy, 20 grand, 20, 25 grand is
Depends on the size.
depends on the size of the home. This is what you can put a ground source home in. You can heat your home with just raw electricity, a resistance coil. That's really expensive. From an economic standpoint, don't do that. But one we are seeing a little more of is heating with electricity using a refrigerant-based system, a compressor. We have a number of our buildings here at the university that use refrigerant-based electric heat. VRF systems is the one we use the most, but there are types that you can, and it is fairly efficient. So that's another option. So those are kind of some of the options you can look at we're going carbon neutral when it comes to space heating. Water heating. There's really only three. You can heat with just raw electricity, resistance coil. You can do solar thermal. I do see a fair number of those around the state in various locations. At the university, our pool, we get our pool with solar thermal. And then kind of one of the newer ones to the market is electric hybrid heat pumps. We're using heat pumps in a various form to heat hot water. And that's you're putting a heat pump on top of a standard storage tank water heater, and it blows out cold air and heats the water. So in our case at the university, we actually put them in our mechanical room, so we harvest the extra heat off of our motors and use that to heat our hot water for the building. Kind of keeps our mechanical rooms cool too, which is kind of nice. You know, it's worked in a 95-degree mechanical room, that's not very pleasant. So those are some options for water heating. All right. The other big one, space cooling, plug load, and lighting. Pretty much this is all done with electricity. And so really when you talk about carbon neutral capable, almost all renewable energy systems really are targeting primarily making electricity renewable. And so the kind of the idea is if we can switch a lot of our energy portfolio over to electricity, and then you convert the source to a renewable source. And so at that point, though, you want to drive efficiency. It's very expensive to install a whole lot of renewable energy to offset inefficient energy systems. And so this energy pyramid is kind of the idea. The first thing you do is you conserve energy. Don't use it if you don't need it. Then you make it efficient where you can. And the last thing you do is convert it all to renewable energy. So that's kind of going back to this slide. It's kind of that same idea of let's make everything as efficient as possible, but then as far as sourcing renewable energy, we're going to source it from, in the case of the university, solar panels and Rocky Mountain Power Blue Sky, which will actually create for us a renewable energy, a carbon neutral capable campus looking system.
Could I ask a question? How far along are you in making the Weber State University campus carbon neutral? And as you go towards doing that more, I assume wind is not an option because maybe your location is, there's nowhere you could access that, but certainly solar. So are you going towards adding more and more solar to get towards carbon neutral, or what are you doing?
Right, so primarily we are doing a lot of solar. Let me talk on the sourcing side. Yes, sourcing we want to put about 50 to 75%, our target is 50 to 75% of our energy will come from local university-owned solar installations. This summer we're putting a 2 megawatt facility down at our Davis campus. We have a couple installations going on now on this campus.
Are you considering storage? Like, have you signed up for a Powerwall?
No, we may install some power walls for testing and for a few locations. Our strategy is actually to partner on the grid side, is to work with Rocky Mountain Power and
Why?
use. Why?
Yeah.
Um,
I mean, you've got a big facility here. What do you need them for?
Economics. The economics of taking a campus off grid is kind of is extremely expensive.
Okay.
Load balancing across the grid. Rocky Mountain, as a good example, Rocky Mountain Power, their energy demand occurs about 7 p.m., between 4 and 7 p.m. Weber State University, we peak about noon. So our peak energy use is not the time when Rocky Mountain Power peaks. And so it makes a lot more sense to have a central utility that acts as the battery or load sharing system and having an economic model that balances that across. And so for us, I mean, our intent is to stay absolutely tied to the grid and use them.
Are you going to get are you big enough to demand a prioritized exchange for the rate they pay you for the energy that you sell into their grid? Just asking.
We have our own substations, we're on Schedule 9, but as far as we meter, we will net meter under a traditional net meter agreement, so that we do not, we will only sell back at the rate we pay, not including demand. So we still have to pay demand charges for the grid connection. So we still maintain that connection. Now, I go back to your first question on the how far along are we? We are currently renovating a large percentage of the campus mechanical systems. I mean, we have a central plant it's a steam plant. Most of our buildings are coming off of that plant. We have a plan. Over the next probably 15 to 20 years, we'll move our steam plants and convert all of our buildings to this type of a system that can run off. It's condenser loop is really what it is. We'll have water flowing underneath the campus that buildings will pull in and out of to heat and cool.
So you, in a sense, you're going to get to a point where you're simply not using steam heat any longer?
Absolutely.
And is Hill Air Force Base thinking about that? Because you get all your steam right now from Wasatch Integrated Waste Management?
Not all of it, not all of it, a portion of it we do.
Yeah, so everything, all the steam they make, they sell to you.
Correct.
But-
We only come.
And what do they do with the steam they could create during the years when you don't need heat and cooling?
We have a summer minimum requirement for our processes. We have some steam processes for the summer, for the industrial processes.
Oh, okay.
But it's
So
not
you
near
do
what
use this.
we use it year round.
So what do they do with the extra steam that they produce? Just asking.
However, we're working with them and looking at taking some of that excess summer steam and running it through a condensing turbine to generate on site.
So one last question, is Rich here? Or I won't ask this question. Have you considered asking them
We have.
about what they're doing emissions-wise?
No, we don't have much discussion with Mr. Rich in regards to his emissions. That's his business.
No, for us at Weaver State, though, we are converting a large percentage of the campus to mechanical systems that can run on high COP. That's the term I know, high COP. For those that don't know, COP is the concept called coefficient of performance, and this really is the ability to move heat instead of create it. And so with electricity, it's a common term that it's really critical when you talk about carbon neutral capable, is that I can create instead of burning 1 watt of fuel to create 1 watt of heat, I can actually use 1 watt of electricity and move 4 watts of heat into a building. And that's where you can get your cost efficiency similar to natural gas. So for us at the university, natural gas is less expensive, obviously, than electricity for energy, but it's about 3.5 times less expensive per unit. So if my COP exceeds 3.5, I'm actually cheaper to heat with electricity than I am with natural gas. That makes sense. So that's kind of a number that you may have to consider when thinking about what things cost and how you operate them. So for us, that's kind of a magic number, is that COP of 3.5 and financially, we are better off to move towards these carbon neutral capable systems than with traditional natural gas. Kind of a magic number for us. But yeah, we're about 25% through the campus now. So over the next 15, 20 years, we'll finish up. Our new big, huge science lab, 200,000 square feet, has no boilers in it. So it's kind of it actually heats with heat recovery chillers. So it's kind of we're using chillers in the building. Sounds kind of crazy, but for any engineers in the audience, that's kind of insane. But we actually are heating the science lab with chillers. So kind of different. Anyway, I covered as far as I had. So thank you. Any other questions?
I was just wondering if you could talk a little bit about, you mentioned that some of the like monitoring of data points has increased to kind of inform where the inefficiencies are. And could you just talk about some of the, like, I think it's building OS or Lucid that you're using to, just because USU has the same carbon neutrality agreement, we're starting to move down this road too. So I was just wondering.
Yeah, so we have meters on all our buildings, and kind of they refer to what they're doing at the Hill. We have 15-minute interval data on all of our buildings for all utilities. One thing we've actually found that's kind of nice is one of the toughest things to actually meter is steam. Steam is a nightmare to meter. The meters break often, they're terribly expensive to install, and even then they kind of read inaccurate from time to time. So you go to these carbon neutral systems, it's mostly electricity and chilled water, condenser water, which is actually much easier to meter. So it's actually saved us a little bit on some of our metering expenses going in this direction. But no, you absolutely have to know which buildings are driving this. One of the interesting things we found is we've converted these buildings to these carbon neutral capable. If you look at their electrical profile, they look actually pretty close to what they were before the upgrade. The big advantage has been that the electricity in the building stayed about the same, but the building no longer requires any kind of fossil fuels, and it doesn't need a chiller plant. And so all the energy associated with plant energy for that building it just disappeared. So that's, if you take your narrow view of the building, the energy actually looks pretty similar, at least on electricity only. But if you open your view and you look at central plants and steam plants, all of a sudden this building is far more efficient. So that's been a unique aspect. But those are the kind of things metering will tell you, that you should find out exactly how the buildings perform pre and post, and what decisions you learn with bad or good decisions on the building.
What kind of parameters are you using to prioritize which buildings get what upgrades, and if so, is it based on return on investment, or?
We actually use three things. We look at the environmental performance. So what's the environmental impact? That's part of kind of carbon neutral goal. What's the impact on carbon? We'll look, financials, one of the big ones, obviously. You've got to look at return on investment, simple payback. Sometimes we'll use net present value analysis and more advanced financial tools for analyzing. And the third one's actually politics. We're a state entity. And if I can do a project for $200,000, that's a terrible ROI, but the vice president loves it and throws a lot of money at me in the future for another project, I'm going to do it. So one of our projects that fits that category is that we're doing a big, huge upgrade on the event center, replacing all the windows and glazing. The ROI is at 25 years. But politically, it's good for the institution. It needed to happen, and it creates support among the administration for future projects that have much better ROIs. So we actually do great on politics a little bit.
Actually, just one more quick question. So I'm assuming that with your partnership with Rocky Mountain Power, you communicated to them that like you're moving in this direction, or they're not going to be. So do you know if just from what you know, if Rocky Mountain Power has the capability to sign on other schools on the Wasatch Front which sign that same carbon neutrality agreement, if they have like the infrastructure to let all universities have that much renewable energy as part of their portfolio, or is that going to be a change that they have to make?
That's a change fundamentally that Rocky Mountain Power is going to have to make, and how they operate their grid. Getting into kind of an interesting realm is, and this is part for me, this is a maybe a personal I mean, central utilities I think are a good idea. But they tried to pass a few years ago. I know the president's been familiar with the report, a $0.50 fee for rooftop solar at your home, and got just slaughtered. And for my economically, yes, does rooftop solar undermine the economics of Rocky Mountain Power or central utility? Absolutely. But do we need to subsidize that industry for a certain period of time until the portfolio of renewable energy hits a critical point in the economics of how the utility operates? Yes, it should be subsidized. Eventually, a conscious decision Rocky Mountain Power makes. And then they should do some economic analysis showing where that break point is. Is it 30 to 40% of their total load profile? Where is that break point?
Because of what you're doing and what you just said right there about putting the pressure on Rocky Mountain Power and making sure that the rebates, particularly in the category of distributed residential and distributed commercial, continue to get those rebates. Can you, as Weber State, have any input politically in the state of Utah? Can you help the rest of us who are actively advocating for the solar sector in Utah?
I would think so.
You wouldn't think so, you wouldn't think so?
I would. So part of it, I think one of the big goals, again, as part of the university mission is to set an example.
Yes.
So that's kind of the role I see University taking is going out and being an example of how to do this and setting up a partnership with Rocky Mountain Power in such a way that they know how to replicate it again across the sectors.
Do you think you could set up an educational course for the legislative people before the faculty?
If they're willing to listen to me, sure.
No, demand. I'll put you there.
Just back to the actual carbon capable, is that kind of a change to net zero? Is that, some people say they want to be net zero by a certain point, instead you're taking the standpoint out.
Well, carbon neutral capable refers more to the end use function. So net zero says I want a building that's producing and saving as much carbon, kind of it's net zero on carbon. What I'm saying is that may not be the case, but when you design the building right now, you may not be able to make it net zero right now, but it's capable of becoming net zero. And that's really kind of the concept is is, you know, a lot of times people say, well, I want to go net zero, and it's like, well, we can't do it, it's too expensive, so let's not even try. Well, there's kind of an intermediary solution, which let's at least design a building that's capable of becoming net zero in the future. So we don't have to come back in 20 years and spend millions and millions of dollars renovating the building to become even capable of going net zero.
We hear communities saying it now, we're going to be net zero in so many years, so I guess it really, in a lot of ways, they're really just saying, let's be carbon capable so we can get to.
Can you get to net zero? Because I've seen a lot of people say, I want to go net zero, I can't, and all of a sudden, because they can, they kind of go back to the standard design. And I'm saying, don't go back to the standard design, go to this middle ground where you're capable of becoming carbon neutral as the renewable portfolio in the state or options in the state change.
That would be the same way as, I'm looking at setting up a processing facility, and I'd love, because of the marketing story, it's also going to be able, as a commercial building, as a retrofit of a commercial building, to be able to have solar on the roof. And because this particular equipment is electricity intensive, when the power comes in, and it has to be running from the roof and down, we can set it up to be capable to plug in for solar later, right? So that's
Absolutely.
another.
Yeah, many of our buildings, when we build them, will actually stub out electrical to the roof. We may not put solar in right then,
Right.
but it's geared up. These are the kind of things that we do. That's carbon capable.
Well, and I just wanted to thank Hillfield for the good work that you're doing. It's significant. It's not easily done. I don't know that everybody recognizes that Weber State has become a leader, that this campus of the size that it is in the state that it's in has become nationally recognized and has been doing things. What I like about it is here at Weber State, it's become commonplace, this thought process about efficiency, power production, how we move within and out our buildings, and it's become commonplace where so many universities are just starting. The large ones, the medium ones, the small ones. So thank you for the good work. It's not easy. I don't care what brings us to the table, right? I don't care what your motivation is, but it's important that we're smart enough to live within our buildings in a different way than we currently are. And the construction world continue to be challenged to step up to the plate and do things that have a longer lasting effect. So thank you for the good work.
Yeah, for Hillfield. So you've obviously done well beyond the call of duty, so to speak, in regards to what you've done with, with your carbon footprint and all the above. So what set that in motion? What do you think, going back in your history, what made you rise above the norm? And another question, I'd really like to get your PowerPoint, especially on the changing culture stuff. I found it really interesting.
Sure. I think that the close proximity to the burn plant really helped us out because our solar array is pretty minimal, but I think that, the solar array is about 0.02% of our renewable portfolio, and so that's just a drop in the bucket to the Air Force's entire one. But the fact that we have the capability to pipe that steam in and the methane gas, and it's a good payback, gave us that opportunity. So the Air Force looks into these kinds of things at every single base, and it just kind of happens that Hill had a burn plant right next door, and it was going to be economically feasible to do it.
So the next step you have to do though is talk with Nathan Rich, because I don't want to be the person doing this. Jeopardize Mike, but really, that's an enormous burn plant, and look where he is within the Los Angeles airshed in terms of emissions. I don't need to explain it, do I? Okay.
The other thing too that's driving federal executive orders, it drives all DoD agencies to reduce our energy intensity and increase our.
Right, I realize it's a mandate, but you're creating a culture of, now is that similar on all the DoD bases where they're trying to do this culture and outreach?
Yeah, the Air Force Civil Engineers Center at Tyndall Air Force Base kind of drives that throughout the Air Force. So, building that cultural awareness and getting people to buy into it. And they don't, it's like students up here at Weber State. I mean, they don't, a portion of that electric bill, they probably pay for their tuition. So, but if people have, if there's a financial impact on it, and a lot of times at the base of the side of the hill, that doesn't happen. So it's just, it's educating.
Can you tell us again the percentage of the portfolio that the methane comes from, or that methane takes in the burn plant?
Sure. I know the percentages for our portfolio. So the QB rate is 0.02, the methane is 2%, and then the steam is 19%.
Or total, basically.
Right, so.
Where does your methane come from?
Davis County landfill.
Oh, they're piping it out of the landfill?
Correct.
And you're using it?
We're generating it on site on the base. The building that houses 3 combustion generators.
Okay, so you're piping the methane produced by the landfill, which is by the East Gate, and you're piping that into,
Correct.
and you're using it to produce the power for your generators that are generating what, electricity?
2.3 megawatts, and that's getting consumed in the installation.
Oh, in the
Yeah,
installation.
we take advantage of rate 37, so we get a cost avoidance rate schedule.
Right.
We take advantage of that, but because the amount we're producing in the generator facility is far less than the base is closed, we're not exploiting any of that power.
Right. Yes.
Have you included the efficiency gains of being so close to the burn plant and the methane, in those 2% and 3%? Because your efficiency rate is going to be much higher than traditional. Have you taken that into
We
consideration?
can look at that, we can look at that, is there a long way to go to that final determination, whether that's tactical or not.
How long is your arrangement with Washington
We just awarded we just awarded a 10-year contract in October of last year.
You completed the 10-year
We
contract?
just awarded a 10-year contract.
Going
in
forward.
October of last year.
But when did you first start getting the steam from Washington?
I got here in 1986. I know that we've been receiving steam from that facility when it was constructed sometime around the 80s.
Okay, because the incinerator existed before it was retrofitted to produce steam from burning
Correct.
daily household waste.
Correct. Yes, ma'am.
You mentioned a few positions that are unique to Hill Air Force Base. Are those positions that are going to become more popular, and are they government or civilian?
Positions, you're talking about like our energy outreach
Yes.
coordinator? Yeah, they're called REM. What the Department of Defense does is they on resource efficiency managers, they're normally contract personnel. Mary and I have 3 contract personnel that support us in the office on a day-to-day basis, and we could not accomplish the things we do without their support. So it's called REM, Energy Management Support Personnel, and they're typically contract positions.
What percentage right now of the people who work on base, you said approximately 25,000 military, what percentage of that is military and what percentage is that non-military?
The numbers I've heard is there's like 4,000 military reservists on the base. So that leaves 19,000 plus contract